Hey class, in this video I'm going to be talking about some terms and some technical things related to digital images. That's our first section in the class. Let's take a look at that actually over on Brightspace. Let's make myself a little smaller. So you can see, if you go over to the Open Lab from Brightspace and go to Topics and then Image, we'll be doing a demo in the next video and talking about how to use Photoshop. But for now, we're just going to be talking about some basic terms and technical components of creating digital images. And so this is just to kind of set us up so we understand what we're talking about when we get into our first demo. So there's going to be some kind of like technical stuff to this. You don't really have to like memorize all of this stuff, but I think it'll be a good background to understand what we're going to be looking at in our first demo. So in our rundown, these are all the different terms we're going to talk about. Just starting out with basically like what is a digital image. So a digital image is like a digital representation of an image. There's lots of different types of images in the world, like a painting is an image, a photograph is an image, a drawing. All of these are just kind of, graphic representations of things that we see in the world, or, renderings of, could be a mountain range or a landscape or an abstract, shapes and colors. On the computer, we represent all these things basically as like big squares or rectangles with color and position information. And so let's take a look at an image. I'm going to go over to images, to Google Images, and I like to use a little lizard image for this example. I'm going to filter for Creative Commons images. I'll talk about that a little bit more in another video. And I like to use this little image of this lizard from Wikipedia. So I like to find this guy. So this is on Wikimedia. It's a good website for images that are on Wikipedia. And there we go. So let's download this image onto our computer, and then I'm going to open it in Photoshop to talk about some of the different properties of the image. You don't have to do this. This is just kind of a lecture part. I'll go over all the kind of like technical aspects of what I'm doing in the next video. But let's go ahead and download this image. So I can right click on the image and go to Save Image As. I can also click on this image and it'll go over here. And I can also hit Command S or Control S and save the image. So that's going to save it to my Downloads folder. And if I click on this little folder icon, I'm in the Chrome browser, by the way. So if you don't see that, you might be in Safari or something like that, but don't worry about that for this particular lecture. So there's my lizard image. And if I right click on that, I can open it with Photoshop. And so there we go. So there's our image, and we can use Photoshop to kind of edit it or make changes to it. We're not going to do much with that. I'm just going to use it as a way of looking at the image for now. And Photoshop, as you can tell from the name, is a photo editor. So most of the time you're using Photoshop, you're going to be editing photos. There's a lot of other, design software like Illustrator and Animate that do different things. And there's a little bit of overlap in those programs, but they all kind of have their main focus. And Photoshop is focused on editing photos. So let's see, what do we want to talk about next? So let's talk about pixels. So pixels are the sort of like way that we describe a raster image. I'll talk about raster versus vector in a moment. But yeah, let's look at some pixels. So pixels are essentially little squares of color, and when we squish them together in a big grid, it creates an image. And that's the way that we sort of create a digital version of a photograph, which is a image of something from the real world. So if I zoom in on this, eventually the closer we get to the image, we start to see these little blocks, these little squares of color. And those are pixels. And if we zoom out, when we get really far away, we can't see those lines between the different pixels because there's so many of them. But when we zoom in, we do see these pixels. So that's how we represent images on a computer. A computer screen or a phone screen is made up of a bunch of tiny little lights, and we can mix different color values together to get different colors. And so when we do that, we create an image. So that's why we represent image data as pixels, because that's how it's rendered on a computer monitor or phone screen or a tablet screen or whatever. And so let's talk about the color format. So you can, most digital images are gonna use the RGB format. And when you look at an RGB color, it's gonna be in the range of 0 to 255. So let's look at some of these colors. I'm gonna zoom out a little bit and see if I can find some variety of colors, maybe like where these reds are. There's a lot of different colors right here. Yeah, here's a good sampling. So you can see there's a lot of distinct colors here. So if I open up my color picker, you can see the color that's going to be represented. So if I use this little eyedropper tool and I click on a color, you'll see the color value here. It's a little bit hard to see because these guys are pretty small. If I zoom in on this for a second, you'll be able to see what I am looking at here. Uh-oh. Zoom out for a second. Okay, let's try that again. Okay, so you can see there's a few different ways of thinking about color, but the one that is that we're going to use, most of the time is RGB. And so RGB is just a mixture of red, green, and blue. And when we mix those colors together, we get different values. So I'm going to zoom out a little bit, and you can see if I put 0 for red, 0 for green, and 0 for blue, we're going to get black. So there's 0 of each one of those color channels, and the resulting color is black. If we add, for example, a lot of red, so here's the red channel, so the higher the red value goes, the more red the color will be. And if we mix in some green, the mixture of red and green gives us yellow. If I go back and take out that red, now we get green. And if I add some blue in there, we're gonna mix some different colors together. And if these numbers are all the same, like if they're all 200, we're gonna get a gray value. So you can see the gray here. If all the colors are evenly allotted, then we get a neutral value. So that's how we get gray. And if we have a full color for each one of our channels, 255, we're gonna get white. So that's how we represent colors, is through those 3 digits. You can see there's other ways of doing this, but RGB is the main way to do it in a digital context. So you might be wondering, why is 255 like the highest number here? Like if I put 1,000 here, it's just gonna go back to 0 to 255. So let's take a minute. This is gonna be a little technical, but let's take a minute and talk about the way that we save data on a computer. So I'm gonna move this guy over here. I'm just gonna do a little bit of drawing. Oh, there's a lot of pixels. Let's zoom out. Okay, let's put this lizard guy up here for a second. And I'm gonna open my drawing tool. So the way that we save data on a computer is using something called a bit. A bit is like a switch that can either be on or off. So you can imagine like a light bulb, it's either gonna be on or off, or a switch on your wall. So that can represent 0 or 1, off or on. This is a bit. Bit is short for binary digit. Binary just means 0 or 1, so binary digit. So binary is just a way of counting using zeros and ones. We use 10 base, so that means we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 different digits, including 0. And so that makes it easier to count and say, you know, I have $10 or I have $100, whatever. For computers, since everything ends up being a 0 or a 1 on the memory, on the hard drive of the computer, we represent numbers using bits. And so to make the computer more efficient, we organize the bits in different ways. So after a bit, the next sort of piece of data that we have, or style of data we have, is a byte. And a byte is 8 bits put together. So we can take like a little table, divide it in half, divide each part in half, and then divide each part in half again. And this will give us a byte. So we have 8 bits. And the reason, so we're leading up to the reason why we have 0 to 255. So within a byte with 8 bits, we can represent numbers from 0 to 255. So I'll go over how we do that real quick. This is a little technical. You don't really need to know how to do this, but I think it's interesting. Each one of these boxes represents a different number. So the first box is 1, the second box is 2. From there, we multiply by 2. The next box is 4. The next box is 8. The next box is 16. Then 32, 64. I'm going to run out of room. And 128. And the thing that is cool about the way these numbers work is you can add different amounts of those numbers together to get any number you want. So for example, 1 and 2 gives you 3, 1 and 4 gives you 5, 2 and 8 will give you 10, 16 plus 4 will give you 20, and you can add those numbers into any number between 0 and 255. So if we had 0 for each one of these buckets, that would give us 0. So that's the bottom of our range. If we had 1 for every single one of these buckets, that adds up. If we add all of those numbers up, we get 255. So that's how we get that value range. And you'll see that a lot in lots of different properties when you're doing digital graphics or multimedia. We can add these numbers to get any number that we want. Imagine we were trying to do 100. So if we wanted to put 100, we wouldn't need 128, right? That's too big. So let's put a 0 there. 64 might be good. So let's put a 1 there. 32 plus 64 gives us 96. We're getting pretty close. So if we have 96 and we add 4, that gives us to 100. So then we'll just fill in the rest of the zeros. So this little guy here is 100 in binary. So for each one of our pixels, we're going to have a red pixel, a green pixel, and a blue pixel. And each one of those is going to be one of these tables with 8 bits in it. So again, this is a little technical. You don't really need to know all of that, but it might be useful in terms of understanding why we see those numbers when we do. So the amount of data that we save for each pixel is called the bit depth. And so typically, if we have RGB and you might have another channel, which is alpha, which is the opacity of the pixel. We don't need to look at that right now, but you might have basically 4 bytes for each pixel. So that would be the bit depth. That would be how much information you save for each pixel in your image. But most of the time you'll just have RGB. Some images have opacity or alpha. So let's talk about another sort of technical term, sampling and quantization before we continue. This sampling is basically the way that we digitize things. If you imagine taking a photo, so let's say we take a photo of a beautiful mountain range, and there's some trees, and there's the sun, and there's some more trees and some bushes. There's a lot of information here. So in the world, in our eyes and in our brain, we have like almost infinite information. Like we can get closer and closer and closer and closer, and we're never going to see blocks of color like pixels like we do on the computer. We're just going to see more and more definition, more and more detail. On our computer, we can't do that. We have a finite amount of data that we can store in an image or on the hard drive. So what we do is we sample an image. Sampling basically means instead of saving infinite amounts of data, we take little dots across the image. So we might make a grid like this, and we might say we want, this many rows and this many columns. And for each one of these, this is obviously larger, but for each one of these, we're just going to take one color and fill in a pixel there. And we're going to save that as our image. So that's sampling. It's all the samples that we take from a photograph or a piece of data and then save that digitally. And of course, that's what adds up to give us our pixel data here. These are all our samples that lead together to get our image. Sampling and quantization. Quantization is the way that we sort of like format the data. So that's, we take the binary digits, and that can lead to different results depending on what the image looks like. Ideally, you won't notice sampling and quantization. You won't notice what type of format is being used on an image. But if it's very small or it's kind of pixelated or something like that, you will start to see these kind of digital artifacts where you can tell that it's a digital image rather than an original photograph. So that's a little bit of the technical aspect of how this stuff works. Again, you don't really need to know that, but I think it's interesting, and it kind of informs some of the stuff that you'll see when we're using Photoshop. So let's talk about image size and resolution for a moment. Every image sort of has a size, and the size depends on where you want to display it. If you're showing an image on your phone, if you're scrolling through Instagram, you don't need as much data because it doesn't need to fill up as big of a space. If it's going to be on a movie projector screen or a big poster or something, you need more data, so you need more space. In Photoshop, we can go to image, we can go to image size, and you can see the width and the height of the image there. So you can see how many pixels there are. There's a lot of pixels. There's 2,656 pixels across times each line. So whatever, 260,056 times, what was it? 1610. So there's 42 million different pixels on this image. And then you can see the resolution. The resolution is how many pixels there are per inch. This doesn't really matter for us because we're just staying on the computer. But if you were printing stuff or scanning stuff from the real world, then you would start to care about the resolution. We can scale this image. So we could say, instead of 2,000 pixels, I just want it to be like 600 pixels. And we could make these locked together so we can make a smaller image. And so if I do that, our image is going to be much smaller. And when we zoom in, we're going to get to these kind of pixelated blocks a lot faster. So again, the size of the image really matters in terms of where it's going to be. And as we create images, as we create media throughout the class, I'll talk more about what size your images should be. All right, so that's our image size and resolution. So let's talk about raster versus vector. So raster is what we've been looking at. Raster basically is a bitmap image. It's all the pixels in the grid, and that's how we make the image. In computer graphics, there's another way that we can represent something visual. Let me make another layer here, and I'll give an example of this. So in Photoshop, I'll go over more of these tools in the next lecture, but we can make shapes. So I can make like a little circle. And when I zoom in on the circle, one of the things you'll notice is there's this kind of outline on the side. You can see that Photoshop represents this as pixels, but there's this blue line. It might be hard to see in the recording, in the video, but there's this blue line that doesn't get pixelated, and it never will get pixelated because when you're working with vectors, which is what this type of graphic is, when you're working with vectors, you can make the shape as big as you want to, and it will just recalculate how to draw those pixels. So if I make the shape really big, you can see when I zoom in, that blue line is still going to be smooth, even though the graphic is ultimately going to be pixelated. So that's a vector graphic. You can see how vectors are defined. We have these 4 dots, and then we have arcs for the circle, and different shapes will have lines or different ways of filling in. We're not going to use vector graphics a lot in this class. We'll talk a little bit about it in the next video. If you're taking a design class like MMA 100 and you're doing a lot of like Adobe Illustrator, you'll use vector graphics a lot more in that case. Vector graphics are a lot more useful for things like logos or graphic design related things. We could see an example of that if I go to Google Images again, and let's look at the Apple logo. This is a really good example of a vector graphic, basically. So you can see there's really smooth. If we look at this SVG and we zoom in, it's just going to stay smooth. It gets a little blurry actually here because you can't zoom in forever on the browser. But if we downloaded this and put it in Photoshop, we could make it as big as we wanted to, and it would never get pixelated. So that's basically how vectors work. But again, we're not going to use those a lot in this course. These are some of the different files that are kind of related to different graphics. All of this first group are raster graphics. Illustrator and SVG are vector graphics. I'll talk a little bit more about these files in a moment. Oh yeah, there we go. Lizard image versus Apple logo. All right, so I'm actually going to skip this bit. We'll talk about this when we export our files in our demo. The last thing I want to go over is talk about copyright and Creative Commons. So one of the things that is going to be important for this class is that we're going to be using media sources, and we're going to be kind of like putting them together and then creating new things from them. So we're going to be using images that we find on the web. You can use images that you take yourself as well, but when we use images that we find on the web, you probably noticed, or I did this tools and I went to Creative Commons licenses. And basically what Creative Commons is a way of artists can create images or other kinds of media and basically make rules around which you're allowed to use them. So if you just search, on the web for images, you will find a lot of different images with different licenses. You'll find stuff that professional photographers and, graphics creators and people like that have made, and they will have commercial licenses. So they'll say, if you want to use this image, you can, pay for it, or you can subscribe to a service or something like that. We're not going to do that. So we're going to be careful about the types of images that we use. If you find an image online that doesn't have a license and you just want to download it and play with it, there's nothing wrong with that. You can do that. The problem is when you want to publish it. And since we are going to talk about publishing, we're going to talk about how to do that correctly. So when I go to my lizard image, we can actually look at the license information. If I scroll down here, you can see this is a Creative Commons license, and it has a very specific rule associated with it. If we go to the Creative Commons, we can kind of read more about this. Let's go to their website. And so they basically have a few different licenses with a few different rules that stipulate how things can be used. Let's see if we can find their licenses. Okay, so you can see different websites that they use. Let's see about. Okay, so here are some of the basic licenses. So a CC BY, this is an attribution license, so you have to give credit to the creator. So you're allowed to use it for free and use it as part of your project. You just have to say that, whoever made the image is you give them credit. So you just name them, maybe link to their original website or something. CCSA, adaptations must be shared under the same terms. So this is a little more restrictive. This says if you find an image and you use it in your project, you have to make that project have the same license. So it also has to be Creative Commons. So you wouldn't be able to, make a commercial product with it, but you could post it on your blog or publish it. NC means non-commercial. So you can use the project, but you can't use it in commercial projects. So if you're making like a video game or a movie, or a website that you were being paid to use, you wouldn't be able to use those images. And then sometimes this is all three of those together, and then there's no derivatives. So you can use the image, but only in an unadapted form. So, there's different restrictions and there's different combinations of the restrictions. So it's important to know what the rules are for each image that you're going to be using. I'll talk about this more as we actually make some posts and make some projects, but I just wanted to go over some of the basics. And there's a link to this page on the image project page as well. You can see the licenses here, and they even have a search engine where you can search for images and other media that have Creative Commons licenses. So if you want to, instead of using Google, you can use the Creative Commons search engine as well. All right, so that's it for our topic for today. I'm going to go over a few of these things in the next video as well, but our next video is going to be our first demo. So we'll be setting up Photoshop and using it to do some basic stuff for the first time. So I'll see you guys in that next video.